Hello everyone, dobro večer. Has anyone heard about FerretDB before today? Raise your hand if you have. Oh, we have a few people. Nice, nice. So yes, today we are going to talk about FerretDB, and as we are at a Go meetup, I'm going to tell you some insights on how we develop it in Go. My name is Elena Grahovac. I have around 16 years of experience in software engineering, and 8 of them are dedicated to Go. So I will be really happy to share all that experience with you and the things that we do at FerretDB. So yes, as I said, I have around 8 years of experience in Go, and currently I work as a director of engineering at FerretDB. And then let's talk about FerretDB. So first of all, I'm going to talk about MongoDB. And actually, yeah, who has experience with MongoDB? Who has tried it before? A lot of people. Wow, everyone. That's a really popular database. And actually, that's why I like MongoDB, because it's very popular. There are particular things I like about it. So first of all, MongoDB is really great for document-oriented use cases. It's not like always when you can have a regular relational database. Quite often, it's not enough or it's not really suitable. And in such cases, MongoDB fits very well with its document-oriented approach. Then MongoDB has a flexible schema. This is also one of the things we like about it. If we need to run a migration, we actually don't have to stop the database. We don't have to have downtime. It's super easy to change the schema. It's super easy to add extra fields or even like extra databases. It doesn't ask us to do anything. We just insert the data and there is a new database for that data. Then its query language is also really nice. It's very flexible. It's very handy. It's easy to learn. It's easy to use. It's easy to understand. And as part of its query language, there is aggregation framework, which is super powerful. Like, yeah, it allows you to run statistics or some other things. And MongoDB has really nice drivers for all the popular programming languages. Again, it's really easy to use those drivers. There is documentation. There is nice community, which gives us great developer experience overall. Really nice database, right? There is one reason why we might not want to use MongoDB in some cases. There was some change in the license. So before 2018, there was a license called AGPL, and after 2018, they changed the license, and now the license is called SSPL. So what's the difference between those two licenses? AGPL, the previous license. Let's say you want to modify the MongoDB source code, and you want to run it as a service provider. What this license forces you to do, you will have to release the modified source code. That makes sense. Okay, you work with some open source product, and if you modify some code, you need to publish it and open source it as well. Okay, sounds reasonable. What happened when SSPL license was introduced? Now, if you offer MongoDB as a service, you have to release the code around it, what makes it a service. Like, you have to release the whole infrastructure. Let's say you are a cloud provider who runs MongoDB on Windows. In such a case, you will have to release the code of Windows under SSPL, which is obviously not possible. So that really limits the number of cases, especially for cloud providers, that makes it really hardly possible to use MongoDB. But here you might say, okay, I'm not a cloud provider, I'm a software developer, why should I care? Why does it make, what kind of sense does it make? I don't offer MongoDB as a service, so why should I care? I just run it myself, for example. I know how to run MongoDB, or I have a great DBA who can run MongoDB for me, so why should I care? There are various reasons. I will mention 2 reasons. First one is vendor lock-in. So in case you actually want to use MongoDB as a service, there are not a lot of offers. Of course, there is MongoDB Compass, plus there is Amazon DocumentDB, or there is Azure Cosmos DB, and basically, I think that's more or less it. So in case you want to migrate to cloud provider one day, you cannot choose just any provider, your favorite provider maybe. And the second reason is the definition of it as a service is not clearly defined. It's open to interpretations. If we open the license, SSPL license text, there will be a few sentences that I want to show. So what it means as a service according to that license. First of all, it means that we work with some, or we offer some third-party providers that interact with functionality of the program. Then the service that we offer use the drivers and the value of the program. The program here is actually MongoDB. And the service that we offer accomplishes for users the primary purpose of program. So like the primary purpose of MongoDB. This is like super vague. I just wanted to quote it to just show how unclear the license is and how it's hard to understand it. Especially the last sentence is really hard because, okay, like imagine you offer a service, just a service, not a MongoDB as a service. You offer some service, I don't know, like a service that works with users, service that stores some data. At which point of time you will actually meet this particular thing? What is the primary purpose of MongoDB? It's probably to store data. What is the primary purpose of your service? Probably also store and do something with the data or modify the data. So unfortunately, it seems that in some cases, MongoDB can tell you that you run MongoDB as a service even if you don't. Again, we don't know. Maybe they will never tell you that. Maybe in some cases, they will consider you a cloud provider even if, or a MongoDB service provider even if you are not. So with that, the idea to bring MongoDB back to open source is quite reasonable, I would say. And yeah, that's the exact purpose of FerretDB. FerretDB wants to bring MongoDB back to open source. That's our main goal. I would say that's our only goal. Then the next question would be, how do we do it? What's the idea of FerretDB? So the idea is that we can work with the MongoDB drivers that already exist. You don't need to do anything with the drivers. You can just use any driver from your favorite programming language. Okay, in our case, it's probably Go, but yes, you can also use FerretDB from any other language like Java or some I don't know, frameworks like React or something else, like any language that has MongoDB driver. Then we also want to support frameworks and applications that already work with MongoDB. Again, makes sense. If you have your favorite framework, you don't need to modify it. You can just run it as usual, and then you can just connect it to FerretDB. Then again, we want to offer a real, honest open source solution, which will not be like what MongoDB offers now. And another interesting thing, we don't want to store the data itself because it's a hard problem to store the data. It's like a really big topic, how to store the data on one hand. On the other hand, there are already quite a lot of solutions that can store the data, like remember your favorite database. So that's how we can show the schema of MongoDB, of FerretDB. FerretDB works with MongoDB drivers, so we have MongoDB drivers on one side, and we have some storage on the other side, for example, PostgreSQL. And then FerretDB is a stateless proxy between those drivers and PostgreSQL. How to implement such a solution? Let's start from the storage. So like to implement such a solution, we need to make a few choices. One of the choices is which storage we want to use. And in our case, we decided to go with PostgreSQL. Of course, there are reasons why. The main reason is, of course, open source. So we want to be open source. It means that all the things we work with should be open source as well. Also, of course, PostgreSQL is well known for its community. It's a really huge and really supportive community. It's not only about documentation. It's also about people. It's also about talking to people or like discussing various problems or questions with people. It's really great. Also, if you ask, again, some database administrators about reliability, they will probably mention PostgreSQL as one of the databases that offers reliability. And if we talk about document-oriented databases, then we should remember that PostgreSQL has really nice JSON compatibility, including ability to index JSON data and including ability to query JSON data. We will see how we work with those things a bit later. Okay, so now we have the storage, and we need to understand what needs to be done. Okay, we have MongoDB drivers and modified regular drivers on one hand. We have the storage on the other hand. Now the question is how to translate the queries from the drivers to the queries to PostgreSQL. One important thing here is to talk about BSON format. That's the format MongoDB works with. Again, if you worked with MongoDB, you already had it multiple times. Even if you haven't worked with it directly, you had it under the hood in your drivers. So BSON is JSON-like, but it's binary encoded, and there are a couple of things that make it different than JSON. First of all, documents, BSON documents works with key value parts just like in JSON, but the order is important here. So order is preserved in this case. And also, there are some special types in BSON that are not supported or that don't exist in regular JSON. For example, date is one of such types. Let's take a look at an example. Let's say we have a simple, tiny document with the key hello and the value world, and we want to see how it looks like in Bison. So that's basically how it looks like in Bison. First of all, the first header line is the total document size. Then we know what type of the field is. In our case, it's string. Then we know the name of the field, the value of the field, and then we have a special, another special symbol that says that the object is over. So it's like end of object. So on one hand, it might look a little bit complicated. On the other hand, it's like a very strict, a very exact format, so it's possible to work with it. And then the next question could be, okay, we have Bison on MongoDB, we have JSON on PostgreSQL. How to translate Bison to JSON? As we know, there are two things that we need to support. Basically, let's just support them. So we need to store the order, because the order is preserved, and we need to offer a way to store special data type or data type information. Again, how can we do it? For example, like this. So we have, again, the same hello world object document, very simple. And we want to store it in JSON, but like in Bison. So what we need to do in this case? For example, we can offer a schema. And in this schema, we can store the information about the types. For each field, we will store the information about the type. And we can store the order of the fields in the key field. So it adds some more data to our JSON. So JSON, of course, looks bigger than the initial one, but now it is like a Bison. And now we have that particular document to be stored in the database, in PostgreSQL, for example. Okay, so we have this picture. We have Bison between MongoDB drivers and FerretDB, and we have JSON between FerretDB and the storage. And now we need to also have we have to implement some business logic to basically operate with data. And so that's how more or less our layout or how our layers could look like in this case. So we have three layers. First of all, we need to be able to decode and encode Bison to basically parse requests from the driver and to send response to the driver. Then we need to operate the data because, yeah, probably there are some operations that we want to implement on the database side. And then we need to decode and encode JSON with the schema we defined to store it in the database. So those are three important layers or packages in case of Go. And how we started? First of all, we need to work with Bison. So again, because we work with Go, the very natural thing to do it is to offer a dedicated package that will just work with Bison, which will parse it, which will write it, and that's the exact thing we do. And again, as FerretDB is open source, you can just take a look at what exactly we have there. As Bison is the very exact format, it is possible to parse the data and encode it, decode it. Basically, I guess you don't want to operate the data in Bison, so you will have to translate it to some other layer. And this layer of business logic, can be present by different ways. We decided to have this way, to have different, to have embedded Go types for the types that can be supported, being embedded to have standard library types for the types that, again, are suitable. And we have also our own internal types package for the types that are specific to Bison. That's an example of such types. So you can see, for example, for what needs to be long in MongoDB, we use just embedded int64 from Go. For type date, we can use time from the time standard library, but things like regular expressions or maybe binary data or actually documents or arrays, there is no anything similar that can help us in Go or in the standard library, so those things were implemented by us in the types package. And then, okay, now we have Bison, now we have business logic, now we can store the data in PostgreSQL. And again, surprise, surprise, we have manual package to work with JSON. A regular JSON package will not work for us because we need to store the schema, and so we just added our own package, which is a little bit more extended, which allows us to store the schema together with JSON document, and then we can serialize it, we can deserialize it, and then again translate it to the level of business logic. Now we have everything. We have the way to store the data in the database, we have the way to work with business logic, and actually we don't have to limit ourselves with PostgreSQL. We can implement FerretDB with different storages, and that's actually what we do. So why? it should be PostgreSQL. It can be anything, and it can be your favorite backend. How it is possible? Let's talk a little bit about layers that we have in FerretDB. So first of all, obviously we have a layer that handles connections. When you receive a request, first of all, the driver needs to connect to you as a service, so we have a special layer that handles connections. Then we have a layer that reads and writes binary data. That's the place where we work with Bison. Then we have a handler, what we call handler, business logic handler. It's in the internal handler package. The handler processes commands like insert, find, aggregate, your favorite command in MongoDB. And then we have backends. So first of all, it could be PostgreSQL. It could be also SQLite, because somehow people were really interested to have SQLite as a backend and send MongoDB queries to SQLite. It seems to be popular in some cases, like for some embedded cases and some small cases. But yeah, community wanted it, so we implemented it. And also, it is possible to implement any storage, any backend. For example, currently, some people from the community want to implement MySQL as a backend, which is quite also interesting for us. We won't support it ourselves as FerretDB company, but as we're open source, community can also contribute. So that's the exact example where people from community contribute themselves without a lot of interactions from our side. And yeah, there are just some enthusiasts who really want to have MySQL as a backend, so why not? Actually, before we tried, this is of course, our architecture has some history, and initially we tried to copy the handlers completely. So for each database, we wanted to have its own handler, and we figured out that it's not the best approach. It's better to come up with something, with some layers, with some better architecture. And so we decided that handler can be the same for all the storages, and business logic in handler can work with interfaces. And then we just need to define and implement interfaces. In our case, it's enough to have some backend interface for common things, collection interface, database interface to work with small things. And then those interfaces can be implemented by various databases. You probably know in Go, usually it's not a good idea to define interfaces before you have the need to have an interface. So that's, from my experience with Go, this is one of the rare cases where interface is really needed in Go, where you really have a few implementations of basically the same interface. So potentially it sounds like we know everything. We know how to encode Bison, how to decode Bison, how to store the data, how to implement business logic. We even know how to work with different storages. But in fact, in real life, there are some challenges. We want to be compatible with MongoDB. That's our main goal. We want to be compatible with drivers. And unfortunately, it's not enough to know how to encode and decode data to become compatible. For example, it's interesting, but and again, probably if you think about it, it makes sense. Comparing values in JSONB in PostgreSQL and comparing values in Bison and MongoDB is not the same. When you try to order something, or when you try to just compare two values, for example, for filtering, sometimes you might have some unpredictable results. I will not show examples because it will take some time, but I will give you a link where you can see those examples. Also, there are some data types that, again, are quite popular sometimes, sometimes not. For example, not a number type in MongoDB is quite popular. We decided we won't implement it because it's just too complicated and it doesn't make a lot of sense to have a type. But surprisingly, also nulls sometimes give unpredictable logic when we need to compare things, or nested arrays are not always predictable. There is also an interesting thing called -0 in MongoDB. Again, we decided we won't implement it because it's hard to translate it to the concept of Go. Or, for example, there are infinity values that are also not easy to work with. Also, there are some tricky situations when you need to validate commands. Again, if you just run a command as a developer, you run a find command, for example, you kind of expect, okay, you will have some results. If you want to implement that find command, you need to consider different errors, different edge cases, and unfortunately, those edge cases are not always straightforward. Also, in regular requests and aggregation requests, sometimes some things work differently, and sessions is one of my favorite examples, because I think now we have the third time we are trying to figure out how sessions work in MongoDB. And the only way we can do it is through basically working with MongoDB and trying to understand, okay, what are the cases and how it works, and it's not so easy. And there is some other complex logic. So even though we could implement everything quite quickly, now our main goal is compatibility and how to make things compatible, but on the other hand, how to not lose performance while making things compatible. Because basically, we want to have more things pushed down to, for example, PostgreSQL side, so we run filtering or sorting on PostgreSQL. On the other hand, we want to have the same order, we want to have the same rules when we run such queries. With that, it might be interesting how to test FerretDB, how to test such a thing when it's not straightforward how things work, or when there are a lot of edge cases. So here we can remember our main goal. Our main goal is to be compatible with MongoDB drivers. So those drivers are represented through libraries, or they are used in frameworks, or they are used in applications, and it gives us an idea how we can test it. We can use the tests written by others. Luckily, those drivers and frameworks and applications, they have their own tests, for example, integration tests. And in those tests, we can replace MongoDB by FerretDB, just like run FerretDB on the same port and run tests against it. And so we will have some results. We will see what passes and what doesn't pass. But of course, it's not enough. We also need some tests written by us. In our case, we have 3 types of tests: unit, integration, and compat. Unit tests, not real unit tests, I would say, not what quite often people think unit tests are. Unit tests check the logic that doesn't depend on MongoDB behavior. It's just like internal part of FerretDB. They show some examples of non-straightforward logic, so they can help us actually handle those particular cases when sorting is not easy to understand or comparing values is not easy to understand. What is different from the usual unit tests? We decided that we will keep dependencies. We will have dependencies in unit tests. For example, if database is the dependency, if PostgreSQL is the dependency, we will keep it. We will not mock it. We will just run our tests against it just because it's easier to do it. Then there are some integration tests. So for integration tests, because MongoDB driver has implementation for Go, we just use the MongoDB Go driver, and we send requests to the database through this driver. To ensure that we covered a lot of edge cases, we prepare collections with various data. So we try to insert a lot of data into a lot of collections, and we try to cover really different data types, different cases. So then we can see if we filter correctly, if we run various operations correctly. And for those different collections, we had parallel subtests. Thanks Go for that ability to have parallel subtests. And also, because tests can modify the data, we decided that each test that modifies the data will work with its own collection. So then we are sure that the other tests will not modify the same collection, so we don't have data collisions. And what we can do then, we can run tests against MongoDB, ensure that they pass, and then we can run tests against FerretDB and make sure that they also pass. So we just compare behavior basically of MongoDB and FerretDB, and if they behave correctly, okay, we consider such tests pass. But it's not enough. We decided that maybe if we run tests against MongoDB and FerretDB, why can't we run them in parallel and then compare the results? Even easier. So we just compare exact responses from MongoDB and FerretDB, and if responses match, we consider that we are compatible. And actually it really helps us bring even more compatibility, because quite often, like imagine you need to write a test, you define expected results. Quite often, you cannot define exact expected results if you don't know exact fields of the response. And so in this case, it's just easier for us to compare responses. We don't need to compare them field by field. We just compare the whole response, for example. Unfortunately, this approach makes tests the testing takes really long time to pass with this approach, because we have those plenty number of collections, because we have a lot of tests, because we have a lot of subtests. There is a lot of inserts because we need to insert the data. So running tests is really slow. So what we do, again, quite a natural thing. Locally, we only run the tests that are needed. If you modify a particular piece of business logic, we only run tests for these pieces of business logic. And on CI, we decided to shard tests. And so, we have a few different machines that are configured to run those tests. And so we just split this huge number of tests between those machines, and then it, of course, takes less time for them to pass. How we do it? We get the names of all the tests, and then we distribute them by those shards that we have, and then when the results come, we see what passes, what maybe failed, and what we can do with it. And because each test works with its own collection, it's safe to run tests this way. Okay, so like I can talk a lot about tests, but I will better give you links. There is a link to our CI pipeline, so you can see what exactly we run. And we have our own tool that actually does the sharding. Again, it's open sourced. It's on the FerretDB repo. And they had a dedicated talk about testing, so if you want to learn more about testing in FerretDB and why it is challenging, you can just watch it. So, okay, now we know how to write things, we know how to test things, we are ready, almost. As Go developers, we use many other tools that help us, and as we are at the Go meetup, it might make sense to mention them as well. Those tools are quite standard in the Go community, but for those who are relatively new to Go, maybe it might make sense to hear about them again, so maybe you can implement them for your use case, for your services. First of all is development environment. How do we run it? We run simple Docker containers with dependencies. So for example, when you develop FerretDB, you need to have PostgreSQL as a backend, you need to have MongoDB to run tests against it, and maybe some more containers. And so in addition to that, if you initialize database, you might need to have some additional commands. For example, to initialize replica set on MongoDB. Again, we added very simple our own tool that helps us work with those containers and run those commands, as everything else is open sourced. Then, as a task runner, we decided to use GoTask. A typical approach here is to use make and make files, but make files are not super user-friendly, so we decided to use GoTask because it's written in Go, and it has really nice YAML configuration, so all the commands that need to be repeated are run through GoTask. Then, again, as every project in Go, I believe we use linters, and again, as every project nowadays, we use Golang CI lint. We have our own custom configuration. It is actually quite custom. We decided to remove all the linters that just don't make sense for us, and we decided to configure some linters specifically for our case. And we actually have even two configs. One config is like main approach, it's something that should always pass, and one more config is for like some experimentation. For example, sometimes we want to run some experimental linters, maybe some new linters, to see if they can help us improve the quality of our code or help us get rid of some potential problems and bugs, and so that's what we do. Then we have one more approach to manage dependencies. So I already mentioned that we use GoTask as one of the helpful tools, and we also use Golang CI lint, and those tools are written in Go. So if we want to run them on CI, or even if we want to run them on our own machines, we need to install them somehow. And again, that's quite a popular approach. We have a special package called tools, which just has a Go mode file where all those dependencies are listed, and it helps us version tools written in Go. So it's really easy to install those tools or on any setup. That's quite a typical approach. You can see it in many different applications written in Go. And last but not least, how we run CI, how we run GitHub Actions. Again, we are open source, we host everything on GitHub, so it's a very natural choice for us to use GitHub Actions. We run linters, we run tests, we run also some additional security scans, for example, for containers that we use. Then we also have our own GitHub Actions for special checks, for example, for our contributors and actually also for ourselves. We decided that we wanted to check the information of each pull request. For example, the titles of pull requests are used for release notes. So we want them to have specific formats so they look beautiful in release notes. And for that, we added our own GitHub action and like a few more. Our GitHub actions are also open sourced, and again, it's possible to contribute to them. And finally, why am I here and how you can help us? As we are open sourced, everyone can join our adventure to make that great alternative, open source alternative to MongoDB. And so first of all, you can try FerretDB. You can tell us what you think about it. You can start us on GitHub. Our roadmap is public as we are open sourced, and even our sprints are public, so you can see what exactly we do at each moment of time. Please feel free to leave any questions or issues or ideas if you see the ways we can do better. And we have a community links for feedback and for the questions. Thank you, everyone. I have linked to these slides as well, so if you want to go deeper to our packages, you can do it here. And I'm ready to answer your questions, if any. So the question is, why do we convert BSON to JSON? Yes, that's a great question. Thank you very much. So BSON is something MongoDB works with. Do you know any other database that works with BSON as this?
No.
That's the reason why, because databases work with JSON, but not BSON. Actually, there was an extension in PostgreSQL, like, I don't know, 5 years ago or 6 years ago, that was offering some BSON support, but it wasn't compatible, unfortunately.
Really, PostgreSQL cannot work with any data types. You can put there any of binary data, and it's not very.
We need to query this data and we need to order it. So, okay, you can put the data in the binary format maybe, but how you will search it? How you will call queries with where conditions?
It should be text format, yes?
Well, it should be something. JSON-B seems to be that something, because we want to be document-oriented, but on the other hand, we also want to run some queries to basically query the data. So we don't query everything on the FerretDB side.
Okay,
yeah, there is a question there.
Yes. So this one you probably prepared yourself already and expecting. Did you have to fight the garbage collector since programming languages have a garbage collector and also?
So the question is if we had to find a garbage collector.
Although this is not a database, it's actually an adapter running resistance layer.
In case of FerretDB, we didn't have to fight garbage collector because, again, Go has quite a nice garbage collector. Actually, there is also one important thing I didn't tell about is compatibility versus performance. And unfortunately, achieving compatibility is so hard that we don't really focus on performance a lot at the moment. Actually, currently, we start focusing on performance, what we can do better to make it more performant. But garbage collector and everything related to Go itself is not the first priority. There are some things that are not related to Go, but already can help us with better performance. So, no.
Are there some parts with the unsafe code or is everything safe?
I think we don't have any special things. No, I think like just standard Go is enough for us.
And if you just one more about the organization, is this a project of a group of enthusiasts, or is there any company behind and what's the business model?
Okay, so the question is if there is any company behind. FerretDB is a company. It's a startup. We have, I think, around 10 people. We are distributed all around the world. Like we have an engineer in Japan, for example. We have people here in Europe. So we are like, yeah, just a tiny startup.
So what's the paid layer? Is there some services that are paid, or what's the business model consulting?
The question is about business model. Yes, so we had a few different cases. For example, one of the cases was when we supported a special backend called Tigris. They wanted to have that MongoDB interface, so we're developing the backend for them and that compatibility. Another approach could be consulting and basically, yeah, like probably some other open source solutions do. Any more questions? Yes, please.
Do you support sharding?
The question is if we support sharding. No, not yet, because of the same reason. We want compatibility first, but sharding is on our roadmap.
Okay.
Any more? Yep.
You do a lot of testing. Did you find some bugs in MongoDB, for example? Or did you implement that bug for compatibility reasons?
The question is about testing, if we found bugs on MongoDB and if we had to do the same bugs for compatibility question. The answer is yes and yes. So we didn't find heavy, huge, awful bugs. I would say MongoDB works well. If you think about regular cases, I think it's because MongoDB has really nice history, so it's like the logic works like quite straightforward. There are some edge cases. For example, sometimes some similar commands return data in very different formats. And that's unexpected because you expect that similar commands should work similarly. They work completely different. Or basically order is an interesting part. For example, if you compare data when you need to filter data, and if you compare data when you need to order data, sometimes they have like different rules of comparison. To me, it's kind of a bug because like why it should work differently? You compare, you should have the same results. So I would say, yeah, we found some interesting things in the way how MongoDB works. More questions? Wow, a lot of questions.
Do you compare the performance of MongoDB and your database, and what difference?
The question is if we compared performance. So I would say we ourselves didn't compare performance because we know that our performance is not perfect, so it doesn't make sense to compare a lot. But there were some people in the community who compared it, and actually their results were quite good. Like, I mean, of course we are slower currently than MongoDB, we work on it. Yeah. Yep, please.
Is it possible to use FerretDB as embedded database, like as a replacement for SQLite?
The question is if it's possible to use FerretDB as an embedded database. Yes, it is possible. We actually have embedded package. So, for example, if you develop in Go, you can use that embedded package, and then FerretDB will be like a library of your application. And it is possible to use it with SQLite, so yes, it is possible. Like, I mean, it's possible to just run it as a database with SQLite, so you will have FerretDB running that will connect to SQLite. That's one way. Another way, if you write in Go, you even don't have to run FerretDB. You can use it as a library.